Hi guys, in this video we're gonna solve this question. It says find the steady state error for the above system. We have a unit step input and we have a unit step disturbance as well, and we have a unity feedback. So let's get started. As you know, E of S, our error signal right here, this one, is equal to our input signal R of S minus C of S, our output, times the feedback, which is 1, a unity feedback. So that's why we're gonna ignore this feedback and erase it. Now we can write this E of S is equal to R of S minus, instead of C of S, I can write X of S, this signal, let me show it with the red color for you, X of S times this block. So it's going to be X of S times 100 over S plus 2. Now let me take a copy of this figure and paste it down here so that we have a copy of the system when we scroll down. I'm gonna put it right here somewhere, okay? And let's separate it from the rest of the question. I'm gonna put a line like this. Alright, so E of S is equal to R of S minus, now instead of X of S, this signal right here, X of S, I can write D of S plus Y of S. So we're gonna do that. It's Y of S plus a D of S which is both this one times 100 over S plus 2. Okay, let me close this brackets here. Now E of S is equal to R of S minus now let's multiply this first. Y of S times 100 over S plus 2 minus, because this minus will make this negative, minus D of S times 100 over S plus 2. Now E of S again is equal to R of S. Instead of Y of S here, I can write, if you look at the figure, I can write this block 1 over S plus 5 times E of S. So that's going to give us Y of S. So I'm going to put those 2 instead of Y of S. Minus E of S times 1 over s plus 5 times 100 over s plus 2 minus d of s times 100 over s plus 2. Now E of s is equal to, let's simplify this, R of s minus E of s times 100 over s plus 5 times s plus 2. So I did nothing except I just multiplied 100 by 1, which is 100. D of s times 100 over s plus 2. Okay, now as you see, we have E of s in this side of equation and E of s in this side of equation. So we're going to bring them together to further simplify the question. So it's going to be E of s plus E of s times 100 over s plus 5 times s plus 2. This is equal to R of s minus D of s times 100 over s plus 2. Now let's take E of s in common here. E of s times 1 plus 100 over s plus 5 times s plus 2, and this is equal to R of s minus D of s times 100 over s plus 2. Okay, let's close this. Now I need E of s, this guy here. So I'm gonna write it this way. E of s is equal to R of s minus D of s times 100 over s plus 2 divided by 1 plus 100 over s plus 5 times s plus 2. Okay, now that we found E of s, we need to find the steady state error, as it says in the question. Find the steady state error for the above system. Now, what is the steady state error? We know that in time domain, E of ES, ES, the steady state error is equal to the limit as t approaches infinity E of t. So this is the formula in time domain. So this is for time domain. But now we have E of s. This is an S domain. So we're gonna use final value theorem to get the formula for S domain. So I can write that the steady state error is equal to limit as S approaches 0, S times E of S. And as you know, we have E of S, and that's here. So we have everything. Let's go for it. ES, the steady state error, is equal to limit as S approaches 0, S times our function there. We're gonna write it down here, the E of S, and R of S minus D of S times 100 over S plus 2 over 1 plus 100 over S plus 5 times S plus 2. Now we know that R of S is equal to D of S, and this is equal to 1 over S for unit step function. And this is given, so I'm gonna write it here. This is given. And D of S is the disturbance signal, R of S is the input signal, and they're both unit step function. And we use U of t usually to show the unit step function, and the transform is 1 over S. Okay. Now back to finding the steady state error. We're gonna write it here. Back. We're just gonna replace D of S and R of S by 1 over S. Steady state error equals limit as S approaches 0, S times 1 over S minus 1 over S times 100 over S plus 2 over 1 plus 100 over S plus 5 and S plus 2. Now this is a simple limit question. So now E of S is equal to, we can cancel these out here and we can write it this way. Limit as S approaches 0. Now we can write this as 1 minus 100 over S plus 2 divided by 1 plus 100 over S plus 5 times S plus 2. Now the steady state error is equal to, we're gonna apply the limit, so it's gonna be 1 minus, instead of S0, so we're gonna have 50 there, 1 plus 100 over 5 times 2. Now the steady state error is equal to negative 49 divided by 11. So this is it. This is the answer. If you like this video, please give me a thumbs up and subscribe my channel and wait for my next videos. Thanks for watching, guys.